I'm Patrick Bailey with IQless.com. Today is March 24th, 2022, and in this video I'm going to be recreating the PVC pipe OpenScad code and show how it all works. Okay, so I'm just going to start with a brand new blank file. Now I do have the other code sitting next to another page, so I can kind of reference it and make sure I'm kind of using the same terms and variables and all. We'll see how it goes. So here we go. So first of all, we'll just start here and I'll just kind of put some comments in here like I did before. Created by Patrick Bailey, IQless.com. Boom. There we go, just some comments. Now one thing I like to do, partially because of laziness, is you can kind of set the facets. So there's the facets. I usually just do 200. The higher the number, the more detailed it'll be. So if you do a circle, well, we can show you. We can do a circle, a 50, boom. So if I do a circle, you'll see that looks pretty smooth. Now if I change that to a 10, you can see it turns into, well, if I change it to 6, I'll make it a hexagon. Boom. And actually, sometimes it's nice to use that feature because you can actually, if you really wanted a hexagon, you could say make it a circle, make a hexagon. And you can actually do that within the circle itself. I have to go, let me see if I can, well, that's not the purpose of this video, but you can actually do a circle and you can tell it to use a lower setting just on that one object. But I don't need to do that for this video, so we'll go back to the 200. There we go. And also when I'm hitting this button, that's just doing a quick preview, and that's the actual render. So we'll just do quick previews here a lot. So we'll start at the beginning. So we want to do the base. Boom, boom, boom. The base. Okay, but in this case, I want to do nice little modules. So we'll make a module, and let me see what I have for my base. Oh, there we go. Base. So in my case, looks like the one I did before. I made a module, and it has I'm using the diameter and the thickness of that guy. So we'll come up here and we'll make some universal variables that I'll pass down. And here's, well, we'll show some aspects about that. So we'll say, what am I going to say, diameter? I'll say outer diameter. Outer diameter. Outer diameter is 44. And we'll say thickness. Well, we'll call this the support thickness. Let's call it support thickness will equals 16. Now when you do this in this fashion, since I have a module, if I run this, it will set these variables, but if I run it, nothing gets drawn at all. So if I come down here and I'll say circle, and I'll say diameter. I'll say D equals diameter. Boom, boom. Nothing's going to get drawn because I'm not calling this module. So I'm coming down here, setting that. I'm making this module. It's kind of a tool I can reuse, but I'm not actually calling it. So I'll say base, boom. I'll say, let's do a couple of things. Let's show some experiments with this thing. So here I'll have, I just commented this section out. So now this base has no variables. So now if I do this, and I'll do, rather than that, I'll say outer diameter. Okay, what do you complain about that for? Oh, right there. Oh, that's why. So I'm calling this base, boom, and there we go. And technically I could call the base again. Call it twice. And it actually draws it twice, they're the same thing, so you really can't tell. Now in this case, this variable is universal. Now if you're into coding and you're used to that kind of thing, that's fine, but let's fix this so we're actually going to use these guys. Diameter and thickness. So we'll say diameter, thickness, and we'll come on down here and we'll say outer, we'll pass in the variables, outer diameter and support thickness. Support thickness, boom. And we'll change that back to diameter. Well, let me leave like that. It actually will be broken. So if I do that, and I come down here, and I do another one, and I'll say that I want to make it really thick, or huge. Let's see, huge and 10. It's not going to use that because that's a different variable. But now if I change that to that, boom. It drew both of them. It drew a small one and a bigger one over the other one, so you can't quite see it. If I go back to this, boom, we'll see that. So now my idea for the outer diameter, in fact, let's see, outer diameter base. Oh, another thing we'll do, we'll add a color here. So we'll say color, it's like I did orange, can't spell today. And that's going to say everything within there is going to be colored orange. So now you can see it's orange, which might be nice to differentiate your modules so you can see what's going on. But if you render it in the final rendering, that goes away. So those colors go away. So it's only for when you're doing the quick render. But it's nice so you can see what's going on. Okay, so what do we got here? Orange. Okay, so my idea here was we're going to use this outer diameter. And the outer diameter is going to be the 2 half circles on the end. And I believe the idea I did is I'd have those 2 half circles, but also I'd separate them in such a way that they would, there'd be a circle length in between them if I thought correctly. Let's see, yes. So what we're going to do is we'll come down here and we'll say translate. Yeah, that's what I did. So we're going to translate, and translate just means move. We're going to move it around the XY plane. And you saw what I did that I can do, you can pass in just XY. You don't have to pass in Z, but you can also pass in Z. And maybe I should do that for completeness. So now if I do that, 0, 0, 0, it's not going to move. But if I put in a 10 here, it moves in the x-axis. Axes, it moved 10 over. And what we're going to want to do is we're going to move it, the diameter over. Boom. So it's going to move 1 full diameter over. And that's based on where it started at. So it was here in the center, 1 diameter over. And then I'll make another one. I'll say translate. Same thing, but I'll do a negative diameter. Boom, 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 boom. And we'll do that circle again. And we should have 2 circles, one on the front and one on the back. And that's kind of what I thought. I said, so basically the idea is there's a circle here and a circle here lengthwise in the circle over here. So we're 3 circles long from tip to tip. That's right. That sounds right. Yeah, because you got that. Yeah, that's the math. Correct. Okay, now the next thing we can do is there's a tool called a hull. And so what a hull does is you take objects, and any of those objects, it will connect them in between. So if I say 2-dimensional objects. So I'll scoot that over. There we go. So everything in between here, it's going to be connected. So if I did, so that gives me what I want. But as an example, I want to do something crazy. I could say, let me make another circle, and we'll put it at 0, and we'll put it at, we'll put it up. You can kind of get cool effects like that because it connects smoothly everything. It's a nice little tool. I like it. But we'll go back to here. Boom. That's what we want. So that's what we want for the base. But even though it appears to have a thickness right now, it actually doesn't. So if we render it, we get nothing. So the next thing we got to do is we got to do a linear extrude. So I'll come down here and I'll do a linear extrude. Boom. And that's where we were using that thickness we passed in as our variable. Boom. And you don't have to tab it in like here, but as a coder, I like to tab it in there because it makes it more readable. Because in me, you see if I highlight this, you'll see it highlights this color over here. That means everything in between there. So we'll extrude it, boom, and we can see it goes up that thickness, which seems very thick. Oh, that's why I didn't call that way. I called it 2x4 thickness, because that's, in my mind, the thing that attaches the 2x4. It looks like I'm using 7 currently. Oh, that's way... Oh, yeah. That's because I got to do that. Boom. There we go. A little more like it. So now there's my diameter. Okay, now, but there's some more stuff we got to do here. We got to put some screw holes in here. So my idea is I want to put some screw holes right at the center of each of those circles. And I know where those are located. So I'll come down here and I'll put a note in here. screw holes. Sometimes it's nice to put a little comment here so you know what that section's doing for, if you need to use it again or review what's going on. Okay, so what we'll do is we'll make, oh, here's an example. I guess I'm doing this. So I'll make a cylinder. Cylinder, boom. And we'll have it be the thickness divided by 2 plus 1. Why did I do that? Oh, that's the lower one. Okay, let me do the first one. So I'll say thickness plus 2. Now, one of the reasons, well, we'll do the first. I'll adjust it. So I'll say thickness, and I'll say 2.5, 2.5. This is just a set number. That's going to be my whole. That's just set. I'm going to use it that size no matter how big I'm going to make this. I don't want to adjust it. And then over here, I can do the FN. I can at the end, in just about everything, do FN equals 6. There we go. Boom. That's going to give me a hexagon. So if I do that, oh, what did I do? Oh, forgot, comma. Boom. Okay, let me comment this section out so I can see what's going on. Oh, boom, boom. There you go. So you can see there's that hexagon, but you can't see it because it's the exact same size as what we're seeing right now. So if we put that in, it's the exact same depth, so it gets hidden in there. So what I did here, on purpose, I just added 2 to it. That way, not only can we see it, but in fact, sometimes you might have an issue potentially with STL files. If you have things match exactly and remove them, there could be a question if there's actually still something there, or it's not a good idea. So when I'm adding things or removing things, if I'm moving things from an object, I like to make it slightly bigger that extends beyond the object, so I can make sure to delete everything correctly so the STL file is made correctly. Or if I'm adding things, I want to kind of get inside of something so that I don't have to worry about either. So right now, adding that 2 is fine for the top, but it doesn't go through the bottom. So we're going to go through the bottom too. So we've got that guy. And we're going to translate it. Translate, boom, boom, boom. And here we got to do the diameter, because if we do the diameter, I'll move it over there. But then I'm going to do 0 and 0 and then -1. And now I can see it right there. You can see it going through. Now, if it helps you at this point, you could come down here. You see that orange we have going on. I could come down here and close out the orange and say, even though I really want to use orange for the whole thing, but right now, just to help myself out, I might say blue. And that can help me visualize this little guy. Boom. There we go. So we can visualize that much better. So we got that one. Now, the next thing we're going to do, now that we're translated over there, we do want to make another cylinder. So there's the first one. Now we want to make another cylinder that's shallower. Cylinder, and I'll say thickness, what do I do, divided by 2, plus 1. I might have to adjust that one, right? 5, I'll make it bigger, 5, 5, and I think I did this, yeah, I did hexagon too. Oh, and I can't spell cylinder. Boom, there we go. So now you can see that below. You can see that popping out in the bottom, but I actually want to pop it on the top. So I need to move that. So I'll say translate. Something, boom, boom. And we'll say 0, 0. Don't want to move in the XY, but we want to move in the Z. And what did I do in the Z? Thickness divided by 2 plus 1. Okay, because again, I wanted to extend a little bit further out. That's why I had the plus 1. But if I do that, if I add it to the top and then I add it to the bottom, that means I'll hit halfway exactly. So that's working out. Okay, good. Okay, so there's that one. Do I do a union of these? No. That's okay. That's okay. So we'll leave that as is. And what we'll do now is we'll take this guy. I'm going to copy it because I want to make the second one. Now I could make a submodule if you want to get really crazy, because I want to make that same guy but in a different location. Is it really worth it to make a module of that when I'm only making 2? Probably not. So I'm going to leave it as is. I'm not going to make it a module. I'm just going to take this and do negative diameter. Boom. And now since I copy these over, we got the same thing. Good to go. Then the last thing I'm going to do for this guy, let's see. I didn't mention. Oh, I'm looking at my code for things that I actually wrote wrong. It's a good time to clean up my code, right? Okay. So now I'm going to come back here. I'm going to comment out this blue because I don't need it. We'll make it all orange. And then if I run it, see, there you go. But what I want to do is I want to delete that from that object. So to delete stuff, you do a difference, and you got to be careful about doing a difference. So we'll start it and close it, and we'll take everything else and move it in a little bit just for readability. So what a difference does, it'll take the first object, first 3D object. In this case, it's going to be this whole guy. I think it takes the first object within a block. So after the difference, here's the first block, which is our big object. And then everything after it, no matter what it is, will get removed from it. Boom. So there we go. That's exactly what we want. So I'm getting that perfect. And if I do a full render, we'll see I'm getting that exactly what I want for right now. Cool. So that part's done. So now next, after our base, what do we want to do? The outer cylinder. Okay, we'll do the outer cylinder. So the outer cylinder is the part where we're going to insert our pipe, right? So I'll come down here, I'll make a module. I'm just copying this from my other program. Outer cylinder, which takes a diameter, a depth, and that 24/7 thickness. And so what we'll do is we'll copy that right now. And I'm just going to put this right next to this guy. And, you know, at this point, what we'll do before we do this, we'll comment that out. What we'll do is we'll make one module to rule them all, right? So here, I'll make a module with all kinds of data in it. We have, wow, that's what's eventually going to be, but right now, I'll copy it. Boom, boom. Okay, so we have this module called PVC pipe holder, and it's going to consist of our base, and we have the outer diameter, and we have the 2x4 thickness. Boom, boom. And if I run it now that I've done that and made that a module to own all the submodules, I'm not going to get anything because I still have to call this original module just like I called the other one. So I'll come here and put a one-liner here, and we should be back in business. Perfect. Okay, so now that we've got that, we will, boom, we will put the outer cylinder. So the outer cylinder will be the next thing. And the outer cylinder needs a diameter, and our diameter is going to be a little different. Let's see, outer diameter, looking at my code over here. So we are using the same outer diameter, which makes sense. Outer diameter. And we have the depth, which is the whole depth. Whole depth. And then we have a 2x4 thickness. We have an outer cylinder and an inner cylinder. That's what I did. Okay, so I've got that, I've got that, but now I need the whole depth. And my whole depth is, boom, 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 30. 30, and we need to add in the whole depth. There we go. Boom. Okay. we had something go terribly wrong. Okay, let's comment that out. Oh, that's why. Because now we've changed this, we actually need to actually do this too. Hold up. We forgot our variable, right? So we didn't know what to do. Boom. There you go. Okay, back, good to go again. So we have 3 variables and 3 variables. Okay, so now we're not doing anything with this yet. But let's go see kind of what we did. We'll come down here, we'll give a different color. So we'll say color red. And do that. Now here's another thing about, aside from colors, and another good thing about doing these modules is I can come down here and say, you know what, I just want to fiddle with this at first. I want them to interact with each other because I just want to see the one. I don't want them covering each other up. So I can just come here and comment that base out real quick. So now we comment that out. So now I can just fiddle with this outer circle. So what we're going to do, we got a couple of variables. So it looks like, well, let's start with the first one. So I'm going to have a circle, and we'll have the diameter equals the diameter. Boom. So we'll just do that. We got the diameter. And then from there, we want to do a linear extrude. And in this case, we're going to do the depth at first. But right now we have, there we go. But there's a couple of problems with this because we, there's a few problems with this. We have the depth, that's how high we want it. That's our variable, that's fantastic. But we want it to be a true depth that does not take up the space that's taken up by the 2x4 base. I mean, I shouldn't say the 2x4 base, but the base. So we want to actually extend that a little bit. So what we do is, now if you were being simplistic, I could do this, 2x4 thickness. If I was just going to stay straight. And if I did that, you see, well, yes. That is a lazy way because we're going to join them. So if we're going to join them, yeah, you could do that lazily and have that thickness like that. But in fact, I'd want to linear extrude it probably a little bit and think about that before I add the other guy back in. But if I did that, that height is exactly what I want. But see, I do have this at the bottom, which I don't like. I think that can cause problems. So in that case, what I would do is I'd subtract 1, and then I'd do a translate. Translate, just to cover my bases. And I would say 0, 0, and go up 1. Now this is not what my actual code is going to be, but I just want to show if this is all you were going to do, that would work. Boom. So I made it the depth I wanted, and I added that 2x4 so I can get that the base, so I can get that thickness in there. That way, this is the thickness I wanted, but then I subtracted 1 because I did not want to. I not want to hit the base, and then I push it up 1. So I subtracted 1 from the bottom, and then I pushed it up 1. So overall, this from here to here is the correct depth. So there's my math. Okay, good. Ugh. But now in truth, we're going to want to angle this. And so once we start angling it, all kinds of fun stuff happens. So what I'm going to do is I'm going to undo this because we're going to have to do some more adjustments. And we're going to undo that translate at the moment. And so what we're going to do is we're going to put a rotate. So we're going to rotate, because the first thing we want to do is we want to be able to rotate angle. I didn't put the angle in there? Oh, I was lazy. Ugh, lazy programmer. Okay, so put this angle in here. Find all kinds of problems with my code, right? So there's the angle, we'll add the angle in, and I'll put the angle here at the front as a variable. And then I gotta put it in there too as a variable. Boom, and I'll put it here, angle, boom. I'm looking at my old code, and what I did not do is I did not put it as a variable you could pass in. I just put it there. Yeah, anyway. Okay, let's just call this pipe. We'll call it pipe angle so we can distinguish them. So pipe angle, boom, pipe angle. pipe angle, pipe angle. Good. And then this just calls angle. So we rotate it. And there's a couple different ways you can do the rotate. Let's see what I did over here. I just did a rotate. Okay. Now you can do a rotate. So I'll rotate it by the angle. But then what you can do if you do it in that fashion, you got to say what plane do you want to do it, X, Y, or Z, or a combination thereof. In my case, I'll do a 0. Let's see what I did. -1 and a 0 and a 0. And that should get us our desire. Boom. And you can see it angled. Now the problem, because I came back here and I'm no longer translating, if I angle it, let me change that angle a little more severe, 15. It's going to angle and it's going to cut off the bottom here. That can be a problem. And also, there's a potential if you go too severe, you're going to cut this off too. So we actually want this filled up and this removed. And also we got to move it up too, because we really want what I want is from this dead center right here, whatever angle I have, I want this length to be the length of the cylinder. And it's not right now because the cylinder is actually based down here. So we want to move it. And then we also got to fix some of this stuff. So that's, this is where we got to do a lot of math. And so what we're going to do first is we got to extend and translate it. So we'll do, and I also have some nudges. Am I even using that nudge? Nope, yeah, I'm using that nudge. So we'll add a little nudge in here too, because we don't want to actually be at the exact same plane. So we can make it match, but we'll add. Well, I'll add the nudge in afterwards. Just I won't forget, right? Okay. So what we need to do is we need to extend this. And let's translate first. Let's go translate. We want to get this in the right position. And so what we're going to do. We want to translate this and push this up. So in simple terms, if we weren't taking anything else into account, we would just want to do the 2x4 thickness, right? So copy that variable, and I'll say, oh wait, actually do 0, 0, and in the Z, bump it up. Boom. So now I got exactly what I want at the moment. So from here to here, right here where it meets is the center, is exactly the center of my circle, and going right up here, that's exactly the height I want that I requested. But I got to make some tweaks because I want this to extend all the way down, and I need to cut that guy off. So what we're going to do is we're going to do an extend. So extend. We're going to add to that cylinder and make it longer to accommodate this extra piece that we need. So we'll call that variable extend, and we'll say sine of the angle times the diameter divided by 2. Because what we got here? Because right here what we have is the radius right here, and what we need is need to extend it down. It's been a while. I have to go look at my math. So here, if we go up here, we have a right angle, and we know what this is, but we want and we have this angle, so the sine of that is going to give us this line right here. So that's how far we want to extend down. Yes. So we have that extend, and we'll call it that's okay. That's going to get us this line right here. That's going to get us how long this line is going to be. But then we have our X and our Y, how we're going to change things. So we'll say, how are we doing? So we come down here to linear extrude, we have the depth plus the extend. Boom. Oh, I got to put that guy there. Boom. So now I extended it, but of course it extends that way, and I need to translate it the other way because I want it to go the other way. So I got to do some more fun nudging. So we have our translate. What do we do? We have 2x4 thickness minus nudge. Okay, so I can come down here to my translate. But now it becomes funny how we want to nudge it because we did the correct extension, but we need to do the translate in the x and y in different ways. So I'm just going to call this nudge x because I want to move this over, and that's going to be the cosine of the angle times the extend. Boom. And we have nudge y equals the sine of the angle times the extend. Boom. And then we're going to come down here and we'll say nudge x. You know what? I shouldn't call this y. I should call it z because I'm doing the z plane. And I'll say minus nudge z. Because what we want to do is I'm going to move this thing, and if I moved it just down, I would get the wrong angle. I want to move it along this axis. So when we do this, we should be pretty good. Oh. Boom. Almost. You know what? I think I did a bad calculation here because I think I'm exposing some of the problems I had because that shouldn't be popping up. I did a bad equation, didn't I? Which, sometimes it's good to do these extreme variables because right now it doesn't get exposed otherwise. Okay, what did I do wrong? Okay, we got to extend. I'm not nudging it yet. Because what I want this is I want that should meet down there, and it's not. Okay, let me figure this out. Okay, so I figured out my problem, which is in my original code. So sometimes it's nice to go back and do these because I fix what was broken. Okay, so what we have here, if I go back and go on this angle, you see the problem is I'm too far below. So what I had here originally, my extension was actually wrong. I had sine of the angle times the diameter divided by 2 the radius. And I actually need the radius divided by the sine of angle. And if you really want to go through the exercise of doing all the wonderful geometry, you can. But that's how far I want to extend it so that I can keep that centered right there. But then what I had is well, we'll look at this z. So the original z that was wrong, I had a sine of angle times extend when I needed the sine of the angle times the diameter divided times the radius. So if we do that, let's just do the z first. You should see, boom, we get it nailed right there perfectly. That's exactly what I want at this stage. And then the x, let's uncomment that. Boom. And we get that moved over because really what I want to do, not count, is I want that to be centered. Center right there. Anyway, so that works. So that was what was bad. So let me just delete all this garbage that I don't need. Boom, boom. Okay. And also I moved it over 20 just so I could see it. Another thing that I can do, just to show you what I'm doing here, if I go back and use this other one that I put in here, that's what it'll be with the extension, and I want to move it down but on that angle. So if I do this, you'll see it goes down exactly at that angle. That's what I want. So perfect. I'll remove that 20, so I don't need that. Boom. So there we go. So we see all that. It looks like it's matching. Life is good. And if I change that angle and make it, 15 degrees, we should see it disappear. What the heck? Oh. and he's broken. Haha. Yet more coding errors, huh? That's a translation error. The Z nudge is, it's my X nudge. Oh, did I deleted the wrong thing. Another error. So I have, that's not right. I have the extent, which is that, divided by the sine of the angle. Ugh. Okay, my nudge X is wrong. Ugh. Okay, one more thing to figure out. Okay, I had to step away for a day. I got busy with other things, but now back onto this. So I did figure out my problem, so we'll continue on. But it's nice to see when someone makes a problem, you kind of see how they fight their way through it, right? Okay, so backing up. So here we got this red guy where I have an angle. And you can see what I'm trying to do is center the center of that cylinder should be hitting right there, and then an angle from there. And what I want to do is I want to have that go down and extend through over here, because otherwise I got this open space, right? So what I effectively want to do, and I made this little blue example, for example. So here we have that red, and all we're doing, you know, the angle, the depth plus the extension. And the extension is, make sure I did that right. Yes. And so I want to just extend it. But if I extend it, which I did, in fact, let me change this extension to a 0 just to show you. If I extend it, it goes to the top. I want it to go effectively to the bottom. There's no, well, what I want to do is I want to extend it to the top and then bring it back. That's what I'm going to do. So just to kind of cover my bases, I have this blue one I made here. So it's the same code. So I made this blue one same, but I changed the rotation angle. I added 180 degrees to it, so now it should flip on the other side. And it's as big as my extension. So I want this to occupy this space down here, but of course it's going to move down to unoccupy this space way up here. So that's just to help me see what's going on. Because once I have that match, it should go right down, and that just is a helper. So we go down here, and so I have some code down here, which I already did. So my extension, yeah, that's correct. Although I do have this nudge. So, well, we'll add the nudge in a little bit later. We'll talk about that. So we have the extension, then we have the nudge, and the X equals something, and then we have the nudge, and the Y and the Z equals something. And then we add those into our, what am I thinking? We add that into our translate. So as we translate down, we have, as we translate it over, we have the nudge X. And then over here, we add in the nudge Z. And what we want to do, we want to make sure we have these both in terms of the extend. And I did a little math, and I did my math wrong, my cosines and sines, but now I got it correct. So what we want to do is we take that extend times the sine, multiplied by the sine of the angle. Boom, boom, and there we are, good on that one. And then for the Z, we have the minus the cosine of the angle. Boom, boom, times the extend. And that should move us right down. So if I do that, we should see, boom, we moved down. We didn't move down further. And if I also, it might be a little difficult to see in its position. So if I go down here to the 0 and I make it, I draw it out into the screen, into the Y, we should see that it starts to, oh, I already did that to the blue, sorry. Let me put the blue back at 0. Okay, we can see they're kind of, let me get right on. We can see they're covering each other up. So that looks good. If I make a -20 on that just to view it, pulls it out. It looks like, boom, we got it. So yay. So I will remove this blue for now. because I don't need it. It was just a guide to help me. So now we've got the red where we want as far as going down. And now just to show that if I change these to 0, both these are just moving. So we should see this go exactly up. And we do. So perfect. That makes me happy. Boom. And also now we see this. Oh, here's another reason to pull it out -20. It should be meeting right exactly there. And if I do -20 to that pulls it out, we can see, yep, it is meeting right there. And when I pull it out, all I did was that. So it's just easier to visualize. Boom. There we go. Okay, now a couple more things we want to do. We do want to cut off that bottom there because it's a little ugly, right? We don't want that there. And also we do want to extend it just a little tiny bit more into this plane just to make sure that it's actually all the way in, not just barely touching, because there could be that possibility when it makes an STL file, it gets confused on which plane is which. So I just have a habit. You don't need it all the time, but I have a habit of just making sure things stick in just a little bit more so that when they're joined together, they're really one better object. Okay, so what we're gonna do is we're gonna we'll add this nudge. So we'll say nudge, and we'll exaggerate it. At first, we'll really only make it 1, but right now I'll make it 10, because sometimes, as I learned before, if you don't exaggerate, sometimes your code isn't quite as complete as you thought it would be. Okay, so then we come down here, and so the extend, if we're gonna nudge it one more in, we have to make this thing that much bigger, because we're gonna nudge it in. And now, luckily, that extension, though, is applied in the X and the Z, so I think, if I'm thinking correctly, I think that's all I need to do, right? Because, boom. Yep, because see, now it nudged all the way through. Well, this way, okay, it's all the way through, because I made it a 10. And I think that's my code, right? Let me just double check my code I did here yesterday with offline. Yep, that we did. Okay, so that's beautiful. Now we'll change this to a 1, because I only want to go in 1. I can make this a -20 just to stare at it as we pull it out. And we'll see, yeah, we are a little bit below. Cool. You know what? Let's not make it 1. Let's make it a factor of this thickness, because that's really what I care about. Because if that thickness all of a sudden is 1, then you got a problem, right? So that thickness right now, what are we, 7? So we'll just say thickness divided by 10. That'll cover our bases pretty well. Yeah, that way, if we change it, we're more adaptable. Although making that 1 millimeter thick would be a little weird, but hey. Now the next thing, let me get this. Last thing I want to do for this cylinder, this outer cylinder, is we do need to lop off the bottom. And so there's a couple ways to do that. So what we're going to do is I'll come down here and I'll just start making a cube. So here is this guy, and we'll come down here and we'll make a blue cube. Blue, just so we can see it and distinguish between the two. Although I'm going to remove this blue eventually. And so we'll say cube, and the cube is going to be, probably 2 times the diameter. We'll make it big because we want to cut that whole thing off, right? Boom. And if I make that, you see how it gets stuck in that quadrant? So now we want to translate it. Based on the parameters. Okay, so what we do need to do is, we'll just do it halfway. So we got the X, Y, and the Z. So we'll do the Y, which should be negative, do the half of it. Oh, it's double the size, so we'll just do diameter. And hopefully that'll pull us that way. Perfect. And then for the X, same thing, minus diameter. Boom. There you go. Now we just got to worry about the X, Y, Z. So what we could do is you could do -2 times the diameter. That's a possibility, which brings you even, if I go down here, boom, boom, brings you right at the very bottom. But there's no reason to cut it at the very bottom, because there could be confusion too, because maybe you're hitting that exact bottom. So what we'll do is we'll just make it right underneath this. So I will raise it up in the Z. So what we're gonna do, we'll bring it down, then we'll bring it up a little bit. So we'll say plus the 2x4 thickness. All right. And that gets us exactly flush with that, right? Still got a problem, don't want it quite there. And then we'll subtract the nudge. Boom, and now we are nicely underneath that, and I think that'll be good. And then what we're gonna do is we will subtract. So we'll do a difference. So come down here and we'll say difference. Boom. And like I said, difference will take the first object minus every subsequential object that's in that list. So it's gonna take that first one and subtract it. And we'll move that over. Boom. So now it's gone. And now if you can't really see it because it's trapped underneath there, but if I did a translate and move the whole thing off after the fact, which I'm normally not gonna do, I'm just gonna do for the purposes of viewing here. Okay, 0, -20, and 0, and boom. We should see, there we go, straight on. You can see it's slightly below and we're getting exactly what we want, so. Much better than what I had before. And so here's my old testing code I was doing. Let me wipe that out because I no longer need it. So I really don't need the blue. I'll put this red up here. I will remove the blue because I no longer need it as a guide. Boom, boom, and we can bring that guy back. Okay, beautiful. So now that, wait, what did I just do? Oh, there's my, that's a good to see. The difference, see, if you click on this, the difference is only including there. You can see the end of it right there. So that is my problem. So we got to do, let's see, that is, and that's red. Boom, boom, and tab those over. Okay, I think we're good now. Okay, good. Messed myself up, but we fixed it. Okay, next, now that we have that, we have the outer circle. Next, we did the braces. So let's do the braces. So the braces, the idea, so we still don't have a hole here. We'll do that last just to cover our bases, because if we do these braces and the braces happen to be in the inner hole, we want to subtract them last. Well, let me back up, because it's just a matter of ordering, because it's a method. We can just order it. So we have the outer cylinder. Okay, so now you can see these are not joined, but we might as well join them. Let's do this. So we'll do a union of these two objects. And now, boom, they're joined. So now they're one piece. But you can we still see a differentiating color. That's just to help us out. But that we're looking good. We're looking good. And then below that, what we're going to do is we're going to make an inner. Let me just copy this over here. Inner circle. Boom. Well, in fact, rather than copy it, the outer circle, inner circle are going to act a lot alike. So we should just have the same parameters, and it should be pretty similar. In fact, wait, can I reuse the code? I didn't think about that, did I? There's no reason not to. It's going to extend a little more, though. It is the same code, basically. Well, here's an example. But does that get confusing? It does get confusing. I'm basically going to do the same thing, but there are going to be a few little tweaks. So maybe it's going to be close. And I could make it one method, but for now, let's leave it two modules. So we'll leave it two modules for now. But maybe I could combine them into one, because we're going to see they're going to be very, very similar. So we have an inner circle, inner cylinder. Well, also for now, it's a good idea for me to make them different right now, because I do want to visualize them, right? So make this one yellow. We got an inner circle, and we're not going to be able to see it because, well, I guess we will, because they're the same thing at the moment. But what we want to do is rather than passing in the outer diameter, we're going to have the inner diameter. Let me go add that variable up here. Boom, inner diameter. And now we're going to have to add the inner diameter as a variable. We're going to pass into that, right? Boom. And now that's going to have to accept that. Oh, pipe angle. I spelled that wrong. Oh, yeah. Okay, so we got the inner diameter. Well, let me leave that like that. There. Because the order you put these in matters. Okay, we'll put that there. Boom, 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 boom. Okay, and we'll come here and we'll say inner diameter. Boom. Okay, so now we can see that is correct. In fact, if we come down here and we put another translate in front of that yellow, just so we can have it stick out. Boom. We'll see, we're getting kind of what we want. Almost, but we have a couple of issues. In this case, I don't want to nudge it in because now that's been nudged, this has been unionized, and I think I want to make this one flush. So in this case, we just won't, we won't have a nudge. So we'll say nudge equals 0, right? And see, I'm going to put the nudge as 0 here because we're probably going to turn it into a variable. Boom. So in fact, I'll come down here and I'll say, just to help us out, I'll say nudge, right? And up here, we'll say we want that nudge to be 0, and in the outer circle, we'll change the outer circle too. We'll come down here and say the outer circle is also going to have a variable nudge. That way I can probably combine them into one thing eventually. And I'm going to say it's going to be that and that. And we'll remove that nudge as a variable, make it there. Oh, I didn't put a comma. Nudge, nudge, remove it. I think we should be good. Perfect. I think we're good. Well, you know what? I need to go prove out on this one. I just want to prove it in my mind, make sure it really nudged like it should. I'm fairly confident it did, but let me do a -40 and we should see it. Oh, a -40. Oh, it does negatives. Okay. Didn't know that. Okay. Boom. See, I get below, so I'm happy. Very happy. Okay, let's get that all back where it should be. Looking good. Now in this case, though, even though I don't want to extend it, I do want to extend it through the top. Which means I need to make another little variable because I want to, I'll just call it a top nudge. Top nudge. And we'll say that's just going to be 1. 1. And that should just add to that guy. And I think that should do it. Maybe. Let me make that number bigger. Huh. Oh, because it is a, sorry. Okay, that's not going to work because it is using that number to adjust everything. And it's actually pushing it down and cutting it off. So I want to extend it without adding that to the extend. That means I just have to add it right there. Boom, there we go. There we go, I see. Top nudge, okay. Because if we add it here, that extend variable is being used here, and so it's actually using it and just pushing it down and cutting it off as it was told to do. Boom, top nudge. There you go. Perfect. Perfect. And there we go. We got our top nudge. I think we're good. I'll remove this translate now that I'm happy with that. And we should see perfect right there. So if we put this top nudge in here, right? And then we add top nudge right there. And then of course here we tell it to be 0 because normally the outer circle, we're not going to use it. Boom. Okay, so we could reuse the code. Okay, so now we have that union, so now we want a difference. Boom, 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 boom. Boom, there you go. Oh, you know what? It's hitting that top, and I don't like that. See that little yellow there? Easily fixed, I think. Because see, we made it flush, which I think still confused it, or could potentially confuse it. So maybe I should just make it a little bit above flush. So can I do a -1 and have it be happy? I can. Sweet. Okay, because that would bump it up just a little bit, and I think that's correct. Well, let me undo this difference so I can see it. And I got to bring back my translate. I probably shouldn't have erased that. Boom, boom. Say 0. -20. Boom. And if I go head on the side, yeah, you can see it raise it up just right there. In fact, I should probably make it -0.5. I think that's good. I think that's all we need. Okay, now, well, boom, we see all that. We see that, and we do the difference. Fine, boom, cool. But since these are now, they're the same. It's the same exact code, so I can consolidate. So I can just say, I can just call this cylinder, call this cylinder, and call this cylinder, and they're both going to use this same code. I think we're good. Boom. Oh, undefined number. Or not. Well, let me undo what I did. I didn't see all those errors fly by before. That one's happy. Well, let's make this one cylinder. Of course, if I do that, we get the same thing. Wait. That's just a name change. Oh, I'm calling it cylinder. That's why. That's a reserved word. That's why it's getting confused, because cylinder is something that gets, yeah, that would be why. Let's not use cylinder. So, just as a test, we can just do, I'm going to put a D in front of it just to prove that my brain is thinking correctly. Yeah, and so if I say D cylinder, which is now going to use the same thing, boom, perfect. So we'll wipe that out. We're looking good. We got the hole. Life is expected. We'll just call it PVC. PVC cylinder, let's do that. PVC, PVC. And that way it's used for the inside and outside. We saved ourselves some code, yay. Reusing code's always good, right? Okay, so now really the last thing we need are the braces. But, before we start getting all that, let's see what happens if we do crazy angles. So if we do 85, yeah, see, it'll work. We start to break because that's, yeah, we're cutting off from that. Whew, since we are 3 times, that is, okay, there's one more thing we should fix there. Now, I'm not going to make this work for everything. So like an 85-degree angle is just not going to work because it's not big enough. That's just not going to work. However, you could get close. Okay, see, there's a problem. Let's say you're getting close because of your crazy design scheme. You chose to do something like this, 65, and see how it's not cutting that off. That's because my box in the bottom is not big enough, because we decided that for this thing to be not too, it can be bigger. So we can just make the diameter for that bigger. So we go to that base, and we got that blue. We made it, right there, translate, We made the cube 2. We can make it 3. If we make it 3, though, we have to do, if we make it 3, we gotta make that 3, and those nudges are okay, but the diameter is 1/2, so we got 1.5. 1.5 times, there you go. 1.5 times, I think we're good. Good, just in case someone wants to do something like that, which you can see it's not gonna really work well because it's gonna cut in, but at least we're giving us as much a possibility as we can with this code. Let's see, 55. Let's see how far we can go to make it actually work. Yeah, you could do about 60. Well, of course, even at that, see, imagine if you're gonna stick your PVC pipe in there, you're not gonna get very far. So you'd have to make it longer or something. You have to come down here and make this 80, and that would probably work. There you go, you could do something. But then of course you're covering that up, so this is not quite designed to do everything, and that's pretty high angle. Okay, we'll go back to what we had originally, 30, and I think I had a pipe angle 10. Boom, there we go. 33, 44, 30. Looking good. Okay, so now we're pretty adjustable, Not bad. Good. Okay, now next thing, which let's see how we're going to do this. We're going to do the braces. So we're going to have to do these braces that attach, but we're going to do them up here because as we attach these braces, the braces could potentially go into the inner circle, and we want to delete that cylinder as we do it, right? Okay, just review what I did. I'm probably going to have to pause at one point in this video because I'll probably have to go back and do some math, but we can get most of it going, and then I'll do some math and show that off. Okay, let's see. Oh, I don't need this anymore. Let me just delete that. Okay, so one more variable we want to add is support thickness. How thick do we want to make these supports? And so the idea is what I'm going to do is I'm going to make, you've probably seen, well, there's the picture. I'm going to have a point right here that goes up to here, that goes up to here, and goes back down, and then crosses over. So a big trapezoid, probably the wrong word. 1, 2, 3, 4. I need to know 4 points. 2 points I know easy because I'm going to line them up right with those holes. The other 2 points I can do some math to exactly nail that. And then once I make that, I extrude a little bit, and then I make a mirrored copy on the other side. So what I'm going to do right now is we'll do it, but we probably won't nail these 2 points. We'll just kind of get something like that to show you the idea of it, and then we'll go back and do the math of it. And I'm looking at my code. I probably need to update it because I think I made some changes, and also we can make it cleaner. So we have the support thickness. We're going to pass that guy in as a variable, and then we're going to accept it as a variable. And then for these braces, because we're going to make more than one, we'll say 1 on each side. We'll have support of the support thickness, boom. And then the angle, which we need. Pipe angle. And then outer diameter. We don't need the inner one. And the hole depth, we need that. And then we also need the 2x4 thickness. And we might need that nudge. So, but I don't know yet. We'll figure that out. And then I don't know. We'll see. I don't have the nudge right now, but we probably have to do that and bring that in. This particular nudge right here. But we'll see. So first of all, we'll come down here and we'll say module, braces, boom, and bring all that stuff in. Oh, I forgot to put the semicolon at the end. Boom, boom. And what I'm going to do here is we're going to call another module called brace, because we'll make each individual brace. Oh, not that. Boom, boom. So we have a module that's just a brace, singular. That way we can call it twice. In this case, I'm just going to start off by calling it once. And so we'll come down here and we'll just prove that we're doing something. We'll just make a, I don't know, giant square a cube. We'll make a giant cube. And we'll make it purple. Color purple. Okay. Didn't like something I did. Okay, support thickness. Oh, didn't put a comma there. And something didn't like that. Oh, forgot another comma. And again, since I copied and pasted. Okay. Last time. He hopes. Nope. Boom. Okay, so I got a big giant purple cube just to prove that it actually gets to my code. Sometimes you're going to go in small steps, otherwise it gets really frustrating to try to debug stuff. Okay, so what we're going to do is we're going to do a polygon. So you can, there's a cool thing where you can just do polygons. So we'll come down here and we'll say polygon. Polygon. Oh, and there's the other thing is, if we're going to do a polygon, it's actually going to be done in the XY plane down there, and we're going to have to rotate it. So we'll start with that. So we'll just say, we'll start really slow. We'll say polygon points equals, boom, da-da, da-da, and da-da. So now we put these points in between. So there's, 1 point, 2 points, 3 points, and 4 points. Let me delete that guy. And so we'll just say, we'll say -10, we'll just make these up, -10, 0, and we'll say, then the next one will be a bigger one, we'll say 5, negative 5, 5, and then we'll say 5, 5. I need a new keyboard. My keyboard's, I think I did hit the button, it just didn't come out. Okay. Okay, now I can't really see it because well, you can down there. But we'll do the next thing we want to do a linear extrude, right? And we'll just say 50 just to make a number up right now, right? Even though we do know we do actually know what our linear extrude is, it's going to be our support thickness. But for now, we'll start with that, right? Boom, boom. There we go. And we can see there's our shape cutting all the way through. But you can actually see it suspended right here because we're deleting that circle out of it. So our circle cut's working just fine. But now to make our brain work, we need to rotate this, right? So we'll do a rotate, and I'll say, looking at my code over here, 90, 0, 0, boom, boom, and boom. So now I'm getting it in the plane I want, right? There we go. Now I just got to get the numbers I want. So one, we can get those first numbers pretty easily because those are going to be the diameter. Let's see. So say negative diameter on that first point. Oh, well, outer diameter. Well, I'll change this. Wow, maybe I should leave it. Outer diameter just to outer diameter, boom. And we can see now that point is matching up with that. That's what I want. And on the other point in the front, I want outer diameter in a positive, boom. So those 2 points are matching up exactly where I want. Let me make these different just so we can see it easier. Boom. So those points are nearly what I want. What I really want is I want to raise it to the surface, right? So now we can add in a translate. Translate, boom, boom. And what we're going to do is we're going to translate there, and then don't really care about that yet. 0, and then the Z, we're going to do the 2x4 thickness, right? 2x4 thickness, boom. And there you go. So we have that. So now, but now we're flush. We still want to kind of nudge it down a little bit. And so we'll just make a nudge. And we'll make that nudge, because we might need that number. We'll make that nudge the exact same nudge that we used before for the PVC cylinder. So we'll set that. In fact, we'll just call it nudge up here, right? Nudge. Equals that. Maybe not. Too confusing. I'll just copy. Not that bad. Okay. There we go. Boom. Oh, and I forgot to put a comma in there again. I think my keyboard's done. I swear I'm pressing it. Okay, so now we can see we're passing the nudge in. Nudge. And we're going to say minus the nudge, right? Boom. Need to clean my keyboard out or something. Okay, that's not correct. Okay, what did I do there? Okay, we got the 2x4 braces, thickness divided by 10. That should be fine. Just put a number here. It's not using it. Uses that. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. We got the 6. Oh, this is where variables can. I think we're having some issues with variable naming. Call it a brace nudge. Okay, why don't you go look at that and see what's going on. Okay, I got it figured out. There's just me being dumb. So here we're doing braces. We add a new variable. And we had braces. I forgot to add it to braces. And then to the brace here, I forgot we had that intermediate. We're doing multiple braces. So my bad. But there we go. So we can see we're sticking down just a little bit below. And so there's more work I'm going to do. But for now, that's what we're going to go with. I'm not going to get those 2 points fixed. I'm going to do that. We'll cover that in a bit. Okay, so support thickness. We're going to go change that linear extrude to the support thickness we set, which happens to be 16. And then what we got to consider is, now that we've done that, we also, you see it's kind of in the wrong position because we rotated it, but it rotated it right there at that angle. So we need to do another little translate where we say diameter divided by 2. Outer diameter divided by 2. Boom, and there you go. So now it's on that side, and it's matching up just perfectly, and it's nudging itself underneath. So we're happy with that. Now, and, well, you know what? Let me make those 2 points shorter. Because right now we can see the top here, but you can see it's actually deleting it inside, and I kind of make it clear it is deleted inside. So even though that's cutting through, it's getting deleted. So that's a little easier to visualize. Okay, there's our support. But now we want to make 2. And so what you can do is you can do a mirror, but if you mirror something, you can mirror it across a plane. It'll make the mirror image, but not retain the original one. So there's a little bit of code I found out there just called mirror, which is a mirror and a copy. And so we'll copy that down here. It's just a generic thing you can reuse again and again. It says mirror copy, you pass it something in. Now, the vector does matter. Here, we're saying a default vector, which you can override. And that vector, that's going to tell you which plane to flip it on. In my case, I'm only doing this one flip, so it doesn't matter. I don't need to adjust it. There's the children, you may mirror that, and you mirror that. Boom. So now we're going to come up to our braces, and what we could do, we have the mirror now. So if you have the braces, you could call this brace twice, pass another variable that adjusts it. But it's just more fun and simple to do a mirror. So we'll say mirror copy, and what did I do? Oh, you know what? I'm mirroring in a different plane. This will work. I'll show you where you can override variables. So that's cool. And we'll take this brace. Boom, boom. So mirror is going to take anything inside of here and mirror it. Now it's going to mirror it wrong, if I'm thinking correctly. Oh, it's not going to mirror at all. Oh, okay, I guess you do have to put in that variable. Okay. I thought it would stay, but okay, maybe I'm wrong. So 0, 1, 0. That tells it what plane to mirror on. And boom, we got the mirror. So easy peasy. Now if I change that over here to something else, it's going to mirror in a different plane. Like that. So it depends on what plane you want to mirror it in, so you got to adjust it accordingly if you ever use this mirror thing. Boom. But there we go. So that's it in a sense, because we're joining all this stuff. And so now if I did we're going to do more precise. Let me just hit the creation. And there you go. That's pretty close to what I had, but I do want to nail it so those will actually be much more flush supports. So let me go do the math, because all we need to do for the math is to figure out some sines and cosines to replace these points so they exactly match up flush with those points. So I did the math before, but now we've adjusted things, so I bet you my math's a little bit wrong. So let me go fix that. Okay, I got it figured out, so I'll walk through that. So a little more math, but there we go. So we will change these to, let's change them to something different real quick. Okay, that'll look really bad, but if we do negative 10, 10, 15, and 15. Right, there we go. Boom. Okay. So what we got going on here, we got to set these angles. So what we want to do to get this angle correctly, what we really want to do is we want to get these flush. So we got to do a couple of cosines and sines and all that fun stuff. The first thing is we want to just nail that center on the top here. So I'll hit there. We want to nail right dead center. So we pass those variables in. So I made x1 and x1 and z1 because both sides need that number, and then they need to do the sines and cosines to get over here. So those numbers are the same, but they're just inverse one from another. So the x1 and z1 they both use. So we have that pipe angle times the hole depth. And actually, let me get rid of that nudge for 1 second. And so all I got to do is come down here and say, okay, once I did that calculation, we have the x1, we have the z1, and if I do that, we'll see Boom, I'm getting pretty close there. And I'll do the same, I'll use the same number for that one. Let's see. And Z1. Boom. Boom, there you go. It doesn't really, well, it has to be both be negative. So right there, you can see they're centered, but it's not quite hitting there because I nudged it down, right? So I need to go put that nudge back, just right there. Easy peasy, boom. Now we're nailing that center number. Perfect. And then we need to add and subtract based on the angle, which comes to that x2, which is the cosine of the pipe angle times the radius, you know, and there you go. So now we'll do that for this one, for that one, boom. And there you go. And then we'll do the same thing over here, but reverse, right, other side. And we're nailing it, perfect. So even though, I mean, there are some ideas where you don't want to be flush, but in this case, I think the flush is okay. And in fact, so we're hitting that flush just perfectly, and I love it. And also, this is much more understandable because this X1 and Z1, they're that one position, the X2 and Z2. And so this is much more readable and repeatable than even what I did before. So if I look back over here, look what I did. I just did it right in the middle there. Sometimes when you're a programmer in your rush, you just kind of stick things in there, and it's true and correct. Well, this might not actually be true and correct because we made change. It was true and correct as I did it before, but it gets confusing because it's all lengthy. So sometimes it makes more sense to make the code a little longer and cleaner and more understandable. And I think this is easier to read. But then there we go. We've got it sinking in a little bit right there, right? So we're good to go on these. We got those just fine. So the last step, well, in truth, they're being unionized. So they're being added. So that's perfect. That's exactly what we need. You just don't see it because of the color. So if I save it and I create the STL file, boom, look at that. Looks pretty. And so now that should just work just fine. And so now you can adjust it however you want. I think this is more adjustable than last code. But hey, let's try this. So now if I angle it to 22, we should see everything. Look at that. Beautiful. Everything just lines up just fine. If for some reason I want to make that whole depth longer, works really great. If I want to make, let's try the weird thing. If I do a 0 angle, what's going to happen? Oh, look at that. 0 angle should work just fine. Although it wouldn't make much sense, I could do a negative angle. Yeah, I mean, a negative and a positive are going to give us the same results effectively when you print it out, but it's interesting to see that. Now, of course, when you get too angly here, you can see this is not going to work because that hole, you're not going to be able to get to it. Oh, wait. There's a problem. -50, look at that. I don't think I need to cover this, but let me test this. See, when I went negative, look, I'm not getting that pipe all the way down. But let's see if +50 works. Okay, does +50 work? Okay, +50 works. There's a little, I don't want to say a bug, but a thing where you're not covering every little thing in your code. Now, effectively, if I fix the -50 code, it's the same as the 50 code. So there's no point in fixing it because you can actually still get the same results you want. But let me see, if I do a -10, I bet you we'll probably have a little tiny gap down there on that side. Yep, look at that. Ha ha ha. Even when you think you cover all your bases. Now, for those who are out there who are coders for their real job, you know, we have test-driven development and things like that because you think you wrote code that covers all the bases, but there's always these corner cases or these exceptions, like, you know, who in the world would put in a negative angle? Knowing that a negative angle in this case is actually give you the same results as a positive angle. I mean, it's going to be technically reversed, but what it's going to look like is the same. Who would ever do that? Well, I just did, and look, I broke my own code. Like I said, I'm not going to bother fixing it because there are more things I need to do in this life right now. But it lets you know that, man, how hard coding can be sometimes. You think you covered every single base. And I think for a parametric design where you can change the numbers real easily, I think this is pretty good. I'm covering a lot of bases here. And even then, you know, I threw a negative in there. Didn't work. So, boom, 100. Now I could do a negative 100 hole depth, which I do not want to cover, but what would happen? Oh, it actually went backwards. Well, so some of the stuff worked, some of it didn't. That's funny. But I would never do that. Ay, ay, ay. $77. All right. Ah, crazy. Okay, so I'm pretty happy with this. So I'll go, well, let me adjust it to what I'm actually using. So let me adjust it to 33, 44, 30, and an angle of, well, I did 5, but I think 10's a better angle. Boom. There you go. That's what I'm going to do. So I'll go upload this code, and I'll put a link in the show notes to this exact code as it is. And I'll probably go update the code that's out there on Prusa. I might just keep the 3D image out there the same. But there you go. Sometimes it's a good idea to go back and redo your code because you fix and clean up a lot of stuff. It takes more time to do code that's a little more cleaner and more understandable, but I think there's a lot more understandable than what I had before. And let's see, we're 142 lines of code, and what was I before? About the same. About the same. Okay, well, let's call that a wrap. For those of you who made it to the end of this long video, what did you think? I know I have done very long instructional videos in the past, but I did this one a little different. This time I put out a short video out first, giving a good overview, and covered such things as cost and time to print. Then I made a longer video showing how I designed this part, this video. I think I like the idea, where folks can get a shorter video covering the basics. Then if they're really interested in the design and designing, they can then watch the longer version. And even in the long version, they can skip to the bit they are really interested in. I think I will try this out a few more times, but tell me what you think in the comments.